Intelligence is critical to the making of better policy decisions. It always has been. Today, I want to talk about how AI can improve intelligence and help to reduce the likelihood that decision makers will be surprised and make poor policy decisions as a result. What is intelligence? Intelligence estimates are predictions about the future. They're forecasts of what people will do or what a virus will do. Intelligence analysts use information about the past to make these predictions about the future. And these predictions inform decision makers' choices when they have to make hard calls among different options. Now, as recently as 100 years ago, all intelligence was exclusively human-generated. Spies are as old as history, and they sent back secret information about the capabilities or intentions of their adversaries. And analysts drew together the information they got from multiple sources and made predictions about the likely behavior of their adversaries in the future. That their predictions were sometimes right and sometimes wrong says little about their capabilities as analysts, since information was always incomplete and predictions are always at best estimates with different degrees of probability. But over time, we've learned a great deal about how humans make decisions. And here's the surprise. The evidence is really strong that humans are limited in their cognitive capacity. All of us, to some degree or another, use cognitive patterns as shortcuts to save energy and cut through the complexity in our environment. And as a result, we make errors. Especially when we're making predictions, we often see the patterns that we expect to see. So what we've learned is that our capacity to predict is subject to systematic, not random error. So how then do we improve our capacity to predict? Well, we need help. The important first step to improve predictions is to draw on better data. In the last few decades, we've developed two different ways of improving prediction. The first method has been around for several decades. What do? We build models that make explicit the assumption we are using to predict these outcomes. And then we test the models against outcomes in the past and against whatever data we have in the present. One of the real values of models is we can exercise these models. We can vary the assumptions, and we can see how a change in the assumptions will change the expected outcome. So modeling is very useful when we are trying to predict events that have two attributes. They're rare and they're complex. And we do a lot of that in global politics. I return to modeling later when I talk about the challenges of predicting the fall of Kabul to the Taliban in the summer of 2021. Almost nobody got it right, and that certainly qualified as an event that was both complex and uncommon. How could we do it better the next time? A second tool to improve predictions is artificial intelligence. And AIs can be trained to see patterns embedded in very large amounts of data that arrive really quickly from multiple sensors and multiple sources. And our world looks increasingly like that, studded with sensors and drawing on multiple sources. There are patterns embedded in the large amounts of data that are flowing in now to intelligence analysts. But these human decision makers are unlikely on their own to uncover these patterns. Artificial intelligence can be a real help here. So artificial intelligence can be trained on these very large data sets. Their predictions then validated against another data set. And then here's what's really valuable. These predictions can be tested against new data so that analysts can see the error rate. That is really the promise of AI to improve intelligence. AI can generate predictions that can help decision makers make better decisions than they would without help. How might we use AI in global politics? There are many, many potential applications, and let me just talk quickly about 6, but there are 6 of hundreds that I could identify. First, AI can help in the analysis of patterns in huge data sets of voice communications that intelligence agencies routinely collect from people abroad. These patterns can be very helpful in predicting what adversaries are likely to do. Analysis of metadata, the second one, metadata of who is talking to be whom, can be helpful even when we have no access to the content of the conversation. This kind of analysis, done with the help of an AI, would allow the identification of networks that would otherwise be invisible to analysts. This kind of analysis is so powerful that in democracies, we put safeguards in place on the collection and analysis of these kinds of data, because analysis of their patterns is so revealing. Here's a third area where AI can be helpful. It can help in the analysis of large volumes of financial flows across borders. To track the funding of criminal and terror networks, following the money is one of the most effective ways of identifying ransomware networks, as well as predicting illicit activities of criminal networks and drug smugglers. Fourth way, analyzing satellite data to track movements of people across borders to improve predictions of patterns of migration. Another one that we know has worked, analyzing web data and Google searches with an AI to predict the outbreaks of viral illness and demand for healthcare advice. Had we had that in place, the trajectory of the pandemic might have been quite different. And finally, analyzing transportation networks on land, at sea, and in the air, again with the help of AI, would improve the predictions of critical disruptions in supply chains. We've seen how disruptive these breaks in supply chains can be. So what's the big challenge to using AI and large data sets on all these big issues of global foes? We need large, accurate data sets, and that is still a work in progress. But improvements are coming very, very quickly. When I think about it, of course there are risks, But the benefits of AI to improving predictions in intelligence analysis are significant. And I compare it to what analysts would find if they were using only their naked eye. Now let's talk for a minute about the risk of harm. We all know that data sets will reflect the biases of the people who construct the training algorithms for the AI, or even the data sets. If analysts are not aware of these biases, these predictions will simply reproduce these biases. And we already have considerable evidence of racial bias that is built into the AIs that were constructed to predict the likelihood of criminal reoffending. It is really important that we pay a great deal of attention to the implicit bias that is baked in to the data sets. Data sets can be biased not only by the inclusion of data, but also by the exclusion of specific kinds of data. And if these omissions are systematic, the predictions will be biased. Analysts and decision makers are often unaware of the limits of their data or the bias that is embedded in their data. When that happens, analysts especially will be overconfident in the predictions that they generate. And I know from research on decision making that was poor, that overconfidence is one of the chief errors that analysts make. It is a trap because they convey that overconfidence to the policymakers that they are advising. So as we move ahead in this field, which is changing dynamically in real time, we are already in the world of AI and intelligence. We need to pay extraordinary attention to the error rates of predictions and to the systemic biases in the data that are used to train AIs, all the while remembering that unaided human decision-making is biased as well, but we can't see it, and it is harder to correct. Let me talk about a second tool that is especially useful for predicting rare and complex events. That tool is modeling. And let me illustrate the usefulness of modeling by retelling the story of the fall of Kabul in the summer of 2021. Certainly engraved in my memory are pictures of US aircraft taking off from Kabul airport with Afghans clinging to the underbelly of the planes in a desperate attempt to leave the country before the Taliban consolidated their power. The Taliban had advanced from the south of the country to the north in a rapid sweep, and within 10 days took control of the capital city, Kabul, on August 15th, and cut off escape routes for Afghans who were trying to flee the city. If you saw those pictures, you probably asked, as did I, how could this evacuation have been so chaotic, disorganized, and frankly, shambolic? The answer that came back from US officials when they were asked is, we were surprised. They said that they had asked their intelligence agencies and were told that yes, the Taliban would take over Afghanistan, but not quickly. One large agency predicted that the current government, the government of President Ashraf Ghani, would stay in power for at least 2 years after the US withdrawal. Another agency predicted that the Afghan government would survive for at least a year after US forces withdrew. Those intelligence estimates were updated in early August by all the big agencies. The president asked. The new prediction: the Afghan government might fall by the end of 2021. So there were disagreements within the intelligence community, but all of the agencies that were advising President Biden agreed there was time, at least several months. So the president made a critical decision. He agreed to President Ghani's request not to start the evacuation because that would undermine confidence in the staying power of the Afghan government. Now, what happened here in this story? Predictions drove decisions, as they almost always do. Now, was it different in Canada, where we might think intelligence analysts were less motivated to be optimistic? They had less skin in the game. After all, we in Canada had no troops on the ground. We had withdrawn our forces in 2014. But what we did have were thousands of interpreters who had helped the Canadian Armed Forces, and in so doing put their lives and their lives of their families at risk were the Taliban to take over. And we had fixers who worked with Canadian journalists and also put their lives at risk, and who had helped Canadian NGOs. So were the predictions of Canadian intelligence any better? It seems not. Now, it's true that we in Canada get much of our intelligence data and analysis directly from the United States. It's also true that we had limited independent capacity to collect and interpret intelligence on the ground in Afghanistan. Nevertheless, as one of our senior deputies said, we were surprised. We thought we would have time to organize an evacuation of all the Afghans who had helped Canadians. We didn't have time. And so we left behind hundreds, if not thousands, of Afghans who had risked their lives for Canada. Many hid in safe houses for months, waiting for help that was now much harder to provide. And IRCC, our Immigration and Refugee Agency, was swamped by the imperative to process thousands of files by people who were stranded outside Canada, desperate for help. Yet these people had to be examined as potential security risks. Better predictive analytics would have made a huge difference. But the real challenge was better prediction on when the Taliban were likely to take over Kabul. Predicting when is much harder than predicting whether an event will happen. This kind of forecast is really hard. We have very limited data to train an AI. Even if we could draw on all the available historical cases, and many of those cases would not have been relevant because the context was so different. So what could we have done in early August in the face of uncertainty and the need to generate predictions to inform time-urgent decisions? We could have built a model, making explicit the assumptions of the factors that would drive the return of the Taliban. And in advance, specify the indicators of each of these factors so intelligence analysts would have known what to look for. We could then have fed that model on an hourly basis data relevant to the indicators of those factors, data like the location of the Taliban forces, their distance from the capital, road conditions, their methods of transportation, where Afghan special forces were deployed and where they were stretched, and the rate of the Taliban advance. Using assumptions about the Taliban's preferences, we could have asked the model to predict the pace of the Taliban advance. And then we could have asked the model to update the predictions as new data were generated. The first two provinces in the north of Afghanistan, the heartland of traditional resistance to the Taliban, fell with no fighting whatsoever on August the 5th. How diagnostic were these indicators? Well, to me, they were very diagnostic. And I said quietly to myself, the fall of Kabul is coming imminently. Had our agencies treated these variables as diagnostic, based on an argument that we could have had beforehand about how important they were, we could have had aircraft on the ground in Kabul a week before the Taliban took control of the city. Many of the Afghans to whom we were and are obligated could have been safely evacuated. Time really mattered, and it is accurate prediction that gives decision makers time. In this really difficult case, models working to test assumptions and human judgment working together could have improved predictions. When we think about how a model could have helped to predict the fall of Kabul, we needed to compare it to human decision making that is also biased. That is always the default. The question is not whether we have a perfect model or whether we have a perfect AI, but how do these compare to human decision making that is often also flawed for reasons that we know. So here's why building a model helps. We're forced to make our assumptions explicit. And we're forced to do that in some kinds of AI as well. That is a powerful debiasing tool. We can test alternative assumptions against the data that we have. Considering alternative assumptions is another debiasing tool. If it wasn't the rate of the Taliban advance, well, were there certain provinces that, if they fell, told us that the fall of Kabul would be likely? Alternative models can generate a range of predictions, each expressed with varying level of confidence to decision makers, broadening what analysts can say to policymakers, expressing contingency, and alerting them to the ranges is so valuable to decision makers who have to make these decisions, at best in a world of probability, but more often in a world of uncertainty, and make these decisions with really grave consequences. So let's go back for a moment and put ourselves in the position of decision makers in Ottawa between August the 5th and 15th. Ministers had to choose between starting up an evacuation immediately and undermining confidence in the Afghan government, or waiting and risking that an evacuation would be rushed and put at risk many Afghans who had been on an application list for years. Which harm would you have advised our government to minimize. What evidence would you use? What would you have based your prediction on? I'm going to leave that one with you. Let's consider a second problem of prediction where AI could really have helped. After that frantic evacuation, Afghans who had risked their lives for Canada were dispersed throughout the city of Kabul. Could AI have helped our officials to generate predictions rapidly within a 48-hour period that they could have used to identify and provide documents and visas to Afghans who claimed they had helped Canadians? Many Afghans had applied years before to come to Canada, but processing was very slow. And those Afghans who congregated at the gates of the airport needed one document, a visa from Canada, before they could get into the airport. Could AI have helped us here? Here, large data sets are available of past immigrations, or could easily have been constructed. An AI could have been trained on a data set of refugees that Canada had accepted from war-torn countries and those that had been rejected. A validation set could have been constructed on refugees from other countries. Smart analysts could have paid real attention to the biases that might have been built in to those data sets. And then the AI could have been run against a test set and its error rate established. It's almost inevitable that the predictions generated by the AI would have reflected some of the biases of previous decision makers. But at least the decision makers in IRCC would have known in advance something about the biases and more about the error rate. So back again to the real policy problem that officials faced. If they'd had predictions generated that way, they could have traded off the error rate against the 2-year human-generated delays in issuing visas that failed to reach many of the Afghans in time to be evacuated. What was the cost of those delays? Well, Afghans who congregated at the gates of Kabul airport, but who did not have visas from Canada, were turned back. Virtually everybody who was turned back is now at considerable risk. Funding for safe houses has run out, and there are Afghans stranded inside the country as well as around the world as they await Canadian visas. It's very likely that officials who are working overtime now to process these files are nevertheless making errors that all human beings make. We all make those mistakes, so that is not in any way a criticism of our officials. But when humans make unaided decisions, we can't calculate those errors with any degree of accuracy, nor can we examine the biases. So think of the policy problem this way. We could have trained an AI to generate lists of Afghans that could be evacuated on a time-urgent basis. And here we would be using AI to improve efficiency, knowing that we were going to sacrifice some accuracy because of the imperatives for quick action. The alternative, not to generate any lists because of the short time available and the complex data requirements and the risk of error, which is a major factor for human decision makers, resulted in stranding many Afghans with no access to help. How would you weigh the relative harms and benefits, and what would you advise the minister? In summary, good intelligence is absolutely critical to decision making. It always has been, and it is becoming more and more so. Intelligence is fundamentally a prediction problem. AI and models can each help with prediction, although they do it in different ways, and they're each suited to different kinds of policy problems. We can know the error rate of their predictions. We rarely know our own error rate. We pay a great deal of attention to the systematic biases created by an AI, but far less to the systematic biases that all human decision makers have. So what are the challenges that we face as we move into a world of AI-generated intelligence? How best to combine the benefits of human and artificial intelligence to improve predictions that are essential to better policy? When do we use AI to improve accuracy? And when do we use it to improve efficiency? And how do we trade these two off? What kinds of prediction problems are best suited to AI? And what kind are best handled by models that manipulate assumptions explicitly? In the next few years, we will learn more and get better at meeting these challenges. But we are already in the world of AI, models, and intelligence. Thank you.